Okay, in this video, I'm going to talk about something called function symmetry, and it's best to just see with two examples. So if I tell you that I have a function f of x, which is x squared plus 5, and I tell you I have another function g of x, which is x cubed, and I'm going to graph part of both of these functions. So the first one I'm going to graph just in the first coordinate, the right side, and then the same thing for the second one. I'm going to graph just this part in the first coordinate, first quadrant. So so there's no labels on these axes, so you don't really know the scale. But I've told you what the definition of the function is, and I've graphed part of it for you. And I'm going to ask you, okay, can you fill in the rest of this graph, right? And because you sort of know how quadratic and cubic functions work, you'll probably say, yes, I understand how to fill this in. So I sort of understand that if I know the right-hand side of this graph, the left-hand side is going to look the same. It's going to be a mirror of it. And the same thing for x cubed, but the symmetry is slightly different. So here in the first example, the quadratic, the symmetry of a quadratic is that there's kind of a mirror image from the right and the left-hand side, right? Whereas a cubic function, you know kind of that it's going to go up as when x is positive, it's kind of going in the positive direction here. And then it's going to go down. The y values are going to be negative. Like if I take the cube of a negative number, I get a negative number back. So there's still symmetry. You still know how to fill out this graph, but it's slightly different in that I kind of fill it out this way, right? And both of these functions have symmetry. The function on top has what is called even symmetry. So this function is even because I understand the function is mirrored by the y-axis. And this function has what's called odd symmetry. And this is odd. It's sort of mirrored by, well, one way you can think of it is I kind of flip it across the y-axis and then flip it across the x-axis. It would be good to sort of write down a rigorous way of understanding the symmetry, and we can do that. The way that I can explain this symmetry mathematically, rather than saying I'm just, geometrically, it's saying I'm flipping this thing across the y-axis, I can explain this kind of with a formula as well, or algebraically. The way I can think of it is, what does it mean to flip across the y-axis? It means if I take an x value here, and I look at the same value, the same distance from the origin on the other side, so if this is x, this is going to be negative x. What does it mean that I flipped it across let me get this a little bit more in focus here. Flipped it across the y-axis is that at negative x, the y value is going to be the same. So how do I say that in math notation? What that means is that if I evaluate f at x, it has the same y value as if I evaluate f at negative x. Now, a function having this property for all x, that is what it means for a function to be even. So a function is called even if for every x, this formula is true. Now the function x cubed has this other symmetry. It definitely doesn't satisfy this even property, but it satisfies something similar. So if I look at an x value, I can look at the corresponding y value. So that's f of x, or sorry, g of x here. And now I want to know what is the y value at negative x. Well, what's happening is I'm flipping this across the y-axis, and then I'm flipping it again across the x-axis. And so what's going to happen is that g of negative x is going to be the opposite of g of x. So when I flip across the y-axis, I also have to flip across the x-axis. That's changing the sign. So when I flip across the x-axis, it's changing the sign. Y goes from positive to negative, or vice versa, right? And now, so a function with this property, that g of negative x is equal to negative g of x for all x, this is what's called odd. So this is odd. This is the property that defines odd, and this is the property that defines even. Okay, so these are two symmetries that functions can have, and it's often very useful. You can use the symmetry to understand something about the rest of the graph if you know something.